Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. And in this video, we're going to be talking about some trigonometry, but we're going to see how can we use it to apply to real world situations, or you can just think of it as word problems. So right away, anytime you're thinking of a right triangle, you want to make sure that you're writing these letters at the top: S-O-H, C-A-H, and TOA. Those are going to help with those wonderful trig identities. That way they're easier to remember. So when you go to label your right triangle, which is what we're about to do, you can have those labels there. So again, when you're looking at this right triangle, make sure you can be able to label first. So I'm going to say, all right, find that right angle. Again, that's 90 degrees. The side opposite of that right angle is going to be called your hypotenuse. So we label that as H. Our angle theta, wherever that is at, the side opposite of the side, or the angle theta, is called opposite, so we label that as O. And then that means the side right next to it, meaning adjacent, is labeled as A. And this is helpful because when you go to have these trigonometry functions and their identities, make sure you're writing these labels first. So you have the sine of theta is the opposite over the hypotenuse. We have the cosine of theta is the adjacent over hypotenuse, and we have the tangent of theta is equal to your opposite over adjacent. So again, make sure you're using those ratios for these right triangles. So now for these applications, it reads like this. It says the height of Mount Evans is 14,265 feet. How could the height be calculated? Well, trigonometry can be used to measure things that cannot be directly measured. For example, you can have length across a river, height of the mountain, so on and so forth. And so we're going to say the angle of depression. The angle of depression is the angle between the horizon and an object below that horizon, so it's looking down. And if you notice in that picture right there, it has a little plane, so we're saying, it's looking down in regards to that building on the left. And so then we have the angle of elevation. Angle of elevation is that angle between the horizon and the object above. So we're going to be looking up. So make sure you're saying, okay, if you're on the ground, you're going to be looking up to the top of the building, where if you're in the plane, you're going to be looking down. So this is very key because you need to be very careful when you're using these right triangles, and because the tough part is going to be when we're going from the words to the picture. That is going to be the most difficult part, so be very mindful of that. All right, so now in that first example, it reads like this. It says you are standing 9 meters away from a building. You find the angle of elevation to the top of the building is 50 degrees. Find the height of the building. So let's do this. Let's have the picture first. So I'm going to draw my picture. I'm going to say, okay, I have my right triangle. I can say, all right, if I'm standing here and I'm looking up, this angle is going to be 50 degrees. I'm going to say that here is my building. I'm looking for that amount X, that height of the building. So I can then say I'm standing 9 meters away. So I'm saying I'm standing 9 meters away. And so now I have this, I can label my right triangle. So label that right triangle. Side opposite is the hypotenuse. Side opposite of the right angle is the hypotenuse. Side opposite of your angle of theta is going to be side opposite, so we say O, and the one right next to it is going to be labeled as A. So again, make sure you can take your time and label those carefully. So now we can say, all right, pick my ratio. I'm going to pick the ratio that goes along with it. So which two do I have? Well, I have opposite and I have adjacent. So that means I'm going to use the tangents. I have tangent of theta is equal to opposite over adjacent. Make sure that you can now substitute. So I'm going to sub in my values for my variables. So I have the tangent of 50 degrees is equal to opposite, which is X, over the adjacent, which is 9. make sure when you last step you go to solve. Again, you're solving for x, so you have to use those inverse operations. You're trying to get x by itself. So depending on the situation, make sure you're answering it carefully. All right, so for this one, I'm going to multiply both sides by 9. So I'm going to say x is going to be equal to 9 times the tangent of 50 degrees, which is going to be equal to, well, let's see. All right, I have my calculator set to float, and I have it on degrees already, so I'm good to go. So I have 9 tangent of 50. So I'm going to say that's going to be about 10.7. And this is the key part too. You can't just say, hey, 10.7 is my answer. I need to say 10.7 meters, since we're talking about a distance. So that height of the building is going to be 10.7 meters. All right, so now your turn for number 1. I'll read the question carefully. Make sure you can pause, try it for yourself, set it up using the picture, label, ratio, sub and solve. So Mr. Shank, that's me, is standing 15 feet away from the base of the flagpole. The angle of elevation to the top of the flagpole is 40 degrees. How tall is that flagpole? So you're gonna set it up just like this picture. So try it out for yourself, pause the video, and continue in just a second. All right, so now hopefully you're trying that one out for yourself. On the back, at the top, it says write those big letters here first. That way they're easier to remember. Again, these are your, I keep messing up as well, that's okay. Again, make sure you have SOHCAHTOA at the top anytime you see a right triangle. All right, so for example number 2, you are standing on top of a 150-meter cliff looking out onto the ocean. You see a boat on the water. The angle of depression is 15 degrees. How far is the boat from the base of the cliff? So this is where it gets a little tricky, because you need to be very careful on how you're drawing those right triangles. So what I can do is like this. I can say, all right, if I have my, so let's do a picture first. I can say, all right, I have a right triangle. There's a couple of different ways to solve this, but here is one way. So I have a right triangle. I could say, hey, this 150 is going to be that height of the cliff. So I have 150 meters is that height of the cliff. So that means that we're, at the top here, standing out, looking down to this boat. So I can draw a little boat here. Again, it doesn't have to be perfect. Definitely not an artist, but we can at least try it out. And we're saying, okay, where would I put this 15 degrees? Well, you have to be careful, because we're saying this angle that I'm looking down, because I always have that horizon is always the same. So that means that this angle right here is 15 degrees. So then how much is this angle inside of the right triangle? So that angle of depression is going to be outside that right triangle. So that means that inside here, again, you can do it like this. I know that this corner forms a right angle, so I'd say 90 minus 15 is going to be 75. So I'm going to say that this angle that I need is going to be 75 degrees. And that's important because you need to be able to set this up carefully. And we're looking for this x, which is going to be our distance, that base of the cliff, to the boat. So you can set it up like this. I have my labels now. You can label my right triangle, and I can say, all right, side opposite is going to be h. The side opposite of my angle theta is going to be my side opposite, which is O, and then that means that this 150 is going to be A. So then for my ratio, I can say, all right, looking at these letters, I know that I have O and A, so I'm going to use tangent. So again, make sure you're writing those down for yourself, that way that they're easier to remember. So I have O divided by A. I'm going to say, when I sub in my values for my variables, I have the tangent of 75 degrees is going to be equal to opposite, which is x, over the adjacent, which is 150. Make sure you can get x by itself. So when I solve, I have x is equal to 150 times the tangent of 75, which is equal to, let's find out. So I'm gonna say 559.8, and I can say meters, since we're talking about that distance. So again, be very careful when you're drawing this. A way to check is this. If you're imagining a rectangular shape, and I can draw this in class as well, but if you're imagining a rectangular shape, I should be able to still use that 15 degrees, and I can say it like this. I would say, okay, my side opposite is 150, so that means I would have something like this. I would have, let's see if this works out, 150 divided by the tangent of 15, and I get my same answer. So that'd be, if I drew my picture differently, I'd still should be able to get that same value, meaning that distance x. All right, so now your turn. Still the same way. Make sure you try it out. Pause the video. Be sure to set it up using the picture. Label your right triangle, and then pick a ratio, substitute, and solve. And then so lastly, the very last problem at the bottom here, this is what happens when we need to find the angle. So let me maybe write here as well, so that way we don't forget our wonderful trig identities. So you can tell, I always have those next to me. So it says this, it says an angle. An airplane is flying at 4,000 feet above the ground. The horizontal distance from the plane to the beginning of the runway is 42,315 degrees. So let's figure out what is this angle. So I'm gonna have this picture. So when I draw that picture, you can say, all right, something like this. Oh man, real rough looking picture, but that's okay. I'm saying, okay, the horizontal distance is 42,315. I'm saying this plane, something like this. Doesn't have to be perfect, but at least you can have that idea. I can have that runway at the bottom. I'm saying it's 4,000 feet off the ground. So now I'm looking for this angle right here, this angle theta. So when I go to label, I can say a side opposite of the right angle is the hypotenuse, side opposite of the angle theta is side opposite, and that means that this 42,000 is the adjacent side. So I labeled my right triangle. I need to pick this ratio, and you guessed it, it's still going to be O and A, so it's going to be tangent. So I have tangent of theta is equal to the opposite over the adjacent. Sub it in my values. So I have tangent of theta is equal to 4,000 over the 42,315. All right, so now how do I get this angle theta by itself? We'll have to take that inverse operation, which is the inverse of tangent. So this is where you use that second tan to be able to get that tangent to the -1 power. So I'm going to say it like this. When I go to solve, I have I have theta is equal to the tangent to the -1 power of that same ratio. So of 4,000, and then in the denominator I have that amount. So I have 4,000 divided by that 42,315. So I'm going to say this is going to be about 5.4. And what kind of units do I need? Well, I'm talking about an angle, so I have degrees. So for that one, make sure you can set it up carefully. Since you're solving for an angle amount, make sure it's in degrees. So if you got like a large number or anything like that, you know it wouldn't be true. If I was solving for that side or that hypotenuse, I would know that hey, it'd have to be a number that's bigger than that. But since I'm solving for an angle, it could just be a small angle. So again, use that same setup, solve for your turn number 3, and double check with me. So again, pause that video for yourself. That way you can be sure to try it out on your own. And as always, super slam that subscribe button.